Hello, and welcome to the Opto 22 webinar on energy monitoring. My name is Arun, and I'm involved with energy monitoring products and solutions here at Opto 22. So our goal today is to address the tremendous financial opportunities that can be realized from energy monitoring. In our presentation today, we will give you practical steps that can be taken. We're also going to show you real-world examples of what others have done, how they did it, and what the results were. So that's the plan for the webinar today. But before we get started, I wanted to review a few housekeeping things and give you a little information about the tool we're using, GoToMeeting. So you have your viewer window, which is the window that you're looking at my screen. And to the right here is the control panel. So that orange button there is something you can use to hide the control panel or bring it back out if you need to. And where you would need to is we would like this to be interactive. So throughout the presentation, please submit your questions. Down below on that control panel, you see questions that you can expand and submit your questions throughout the presentation. So please do that. And I also encourage not just questions, but if you have comments or any experiences you'd like to share on the topic of energy monitoring, things you've seen out there in the field or situations you've come across, please submit those as well. At the end of the presentation, we'll also, a survey will launch, and we'd love for you to be able to fill out that survey for us. One last thing before I start, I want to make sure that everybody who's on has audio. So if you look at your control panel, there's a hand there, and everyone who can hear me, please raise your hand by clicking that hand icon. That way I can see who doesn't raise their hand, they won't have audio, and we can see where we're at. So please take a second to click that hand if you can hear me. Okay. Looks like we are good there. And by the way, if you there are instructions for voice over IP or to call in, so you can do that either way. So it looks like we're okay. I'm going to go ahead and lower the hands, and we're going to go ahead and get started. And first thing is the agenda. What we're going to cover today is I'm going to do a brief introduction, and I'm going to address the topic of energy accountability. That's kind of where we are at today. And then we'll talk about the tremendous opportunity for financial savings that energy monitoring can bring. That's kind of where things could go or where we would like to be. With that, I'm going to turn it over to Bill Holmes. We're very fortunate today to have Bill Holmes, who's a consultant in the energy industry for the last 30-plus years. So I'll turn it over to Bill. And what he's going to cover is the topic of facility energy monitoring. And then he'll talk about practical steps on how to proceed. And then he'll go over the benefits of energy monitoring. And at the very end, what he's going to do is share with us actual findings of projects that he's done over the years, what folks did, what the results were, and I'm very excited to have him share that with us because you're going to see some really neat results and some surprising results there. We're going to finish with that at about quarter till, and then we will go over the questions that you've submitted throughout in the comments, and hopefully we can get to all of them. So before we begin, I'd like to start with first a statement and then a question. So the statement is, a typical manager would never approve a major expenditure without a detailed accounting of where the money is spent. I think we can all probably agree to that. So the question I pose to you is, why isn't energy accounted for in the same detailed way? So I'm going to let you think on that for a moment. Let me offer some ideas on why that might be the case. Also, some of the things you see up on the screen are things that we've heard from people with regard to energy. And what it boils down to is accountability. I think the first two things there might be changing, but the rest of the comments there are things that we've heard out in the field. What it comes down to really is, when it comes to energy, whether it's a commercial building or an industrial facility, typically the person, let's say in an industrial example, running the factory or the machine or the process, is not accountable for energy. That bill typically goes to somebody in accounting, and they never see that bill. So their product that they're manufacturing, their process that they're running, the events that are associated with doing those things don't have a direct tie to the energy that's being consumed to do them or to manufacture that product. So what we're talking about today and what Bill is going to go over is the tremendous opportunity that presents itself when you manage your energy costs like you would manage all of your other costs. And that may be the #1 opportunity to boost the profits of an operation, be it a commercial building or be it an industrial facility. But the first step to all this is gathering the data. So you can only effectively manage what you can ably measure. So with that thought, I'm going to turn it over to Bill, and he will take the presentation from here. So Bill, let me go ahead and give you the controls. Hang on one second. And Bill, I'll let you go ahead and advance to the next slide.
Okay, thanks, Arun. Hello, everybody. I'm seeing taskbar at the bottom, Arun. I don't know if that matters or not.
Go ahead and click and see if you could advance to the next slide.
It's not doing it.
Okay, let's try it now. Try it one more time. Oh, there we go.
There we go.
Yeah.
Oh,
so,
let me go back.
yeah.
Okay. Thank you. Before I get started, I've got a couple of things. Arun had a couple of housekeeping things. I'm not used to talking to people I can't see, to see if they're sleeping or nodding their heads in agreement or high-fiving the person next to them if I make a good point. So I asked Arun to he made special arrangements today so I can actually see all of you. So if you'd move over in front of your PC, if you're working from home, you may want to put on your shirt, but so that's better. I can see most of you now, so just give me a wave and good, not bad. But I got a couple of questions before I get started here, and just some background. How many of you believe that audits, models, savings projections, capital improvements, energy management systems, new energy efficient equipment are the best ways to save energy? Just put up your hand. Don't use the GoToMeeting. Just I can see you there. So that's most of you, and that's the traditional way. So how many of you believe the use of accurate data, information only, from an energy monitoring system with no capital improvements can save more than all the others combined, and with a payback often in weeks or months? Not so many. That's very non-traditional. And I tried all of these different things during the last 36 years, and I just want to share with you some of what I've learned. And all I ask today is you keep an open mind for the next hour. So if you promise to do that, let's get started. As you can tell from looking at this, I've been involved with energy actually almost 50 years, counting school, mechanical engineering, thermodynamics was my thing, and then I was involved with instrumentation of fighters in the Air Force from 67 to 74. So I got out in the middle of the oil embargo and went to work starting a energy management department for a consulting firm. And lucky for me, in 74 there was no energy conservation specialty or area, so I couldn't go anywhere for training, so I had to figure it out on my own. And I went a different direction than most of the field has, and I think found a better way. But I worked for the consulting firm. Even though I was heading the department, we ended up doing the consulting thing, which was doing audits and studies and designs and capital improvements. And then I always wanted to know what happened after the capital improvements were done, if it saved any energy or not. And I went to my boss and I said, we need to go out in the field after this is done and see what's happening. He said, well, they don't pay us for that. Once the job's done, that's it. So I said, well, we haven't saved any energy yet. So anyway, he was interested, but he didn't really want to get into that as a consulting firm, get into that area. So luckily, a job opened up teaching for Purdue in the School of Engineering Technology, and I took that as a 40% and a 40% pay cut along the way, which was kind of exciting with 3 small kids. But anyway, so I had to find a way to make some money to make up the difference. And I was so interested in energy. I was teaching thermo. I designed and taught my own energy class, energy conservation. I was teaching thermal systems. And so I started working, talking to some buildings in town that, I mean, this is the 70s. Everybody was concerned. Their costs were doubling. And so I finally came up with an arrangement with the mental health center. And I said, I'll act as your energy engineer, and you don't have to pay me anything. You can pay me, if I save you money, you can give me part of that. So, but I realized after being in the Air Force, I went in that building, I went in the mechanical room, I looked around, I had no idea where that energy was going. I've been designing these systems for 5 years. So anyway, I knew I had to have instrumentation like we had in the airplanes. And so I got an Apple II computer. I took it apart on my living room floor, put it in a panel, soldered my own sensors, built my own cables, wrote all my own software, put a 300 baud modem in there so we could, with the dial-up phone lines, and we put it in this, it was a mental health hospital, and with no capital improvements, I cut 59% off their annual energy costs. And so I was teaching in the day the theory, and I was going out in the building in the evenings and finding out that nothing in the building seemed to be operating according to the theory. So, and so I installed all the instrumentation for 20 years at my cost. I wasn't selling instrumentation, but it's the only way I knew to produce savings. And I thought, boy, I've lucked into the worst building in the country, 59%. Then I went to another one, got 30%. Then another one, 40%. Went to libraries, office buildings, shopping malls. I found the same thing in every building. Once you get the information, it exposes all these hidden opportunities, and through good management, operation, and control, no capital improvements unless our data justified them. So that's how I got started. I ended up teaching these things up at the University of Wisconsin to get taking education. But how did I do it? I built an energy monitoring system. I never sold it until the 90s when I started getting industrial plants. We actually packaged and started selling it. It's continuous, real-time, historic. We can see where every dollar goes that comes through the meter. You can see every piece of equipment. I mean, we went into some detail, but I only put in what was required to save energy because I was paying for it myself. So I found the cheapest way to get the most information to create and verify savings. We could actually go in and see every major system. You could see each department. You could see each area of a building. And when we started, I started realizing that the engineers were not the people that made the decisions about money. We dollarized everything. So and we had historical reports along with the real time so they could see where and when every dollar was spent within a facility. And to me, this seems so simple once you have the data that you're tracking every dollar and where it's spent. They already have a management system. Hopefully most facilities have a financial management system. And it seemed to me that all they had to do was plug that data into that system and use it the way they manage their other costs. And what we found was immediate low-cost, no-cost savings of averaging 30%, some higher, some lower. I was only paid from savings, so we started the very first day creating savings. I was in buildings at 2 o'clock in the morning, turning stuff off. I was back at 5 in the morning, turning it back on, and we ran things manually. We gradually saw it worked. We gradually automated it. And controls can certainly be important, but I think people go into energy projects with the idea that the solution is control, the solution is equipment, and we found that's not true. Most of the problems we found were people problems, and the monitoring system actually allowed us to see everything that was going on within a facility. So I started out doing audits, and then I found that every building we'd look at, and I'd go in and do an audit or a study to try to see if it was a good candidate for our services, I couldn't tell. The things that we would find were hidden. The things that are obvious, lights and things like that, anyone could see that. But So eventually I stopped doing audits, I stopped doing surveys, and my criteria for selecting buildings came down to basically two things. One is commitment by top management. The single most important factor in saving energy is incentive and commitment by top management. If you don't have that, nothing you do is ever going to succeed on a long-term basis. And if this costs were significant, such that it would pay for our services, that's it. So incentive is the most important. People are the key. Technology is only a tool. So every building that I've ever seen, no matter how good it looked up front, no matter if it had an EMS, it had new equipment, it had a full-time manager, I always found huge hidden savings once you got data and once you get into the system. Not necessarily simple. I think part of the problem with energy today is it's been deprofessionalized or never become a profession. People think it's simple. They think it's just turning things off and on. But this is we get into systems in buildings, mechanical electric systems. They're very complex. And look at what's in red in the bottom. It says any areas that have been considered off limits may offer exceptional opportunities. So when you start getting into hospitals and clean rooms and process equipment, originally we did control with our system when we were non-industrial facilities, but when we started looking at hospitals and industrial plants, they said we're not letting anybody touch our critical system. So I took out the control, and it's monitoring only, and that was the smartest thing I ever did, because an independent auditing, verification, unbiased system. And the industrial plants that allowed us to get into their process systems. They wouldn't let us get in there and control them, but they would let us get in and do monitoring. And we uncovered amazing things because no one had ever looked at it before. You take something that's been running wild without data. But how do we do this? How do you get into it? Let's see, I'm trying to advance here.
So you're trying to advance and it's not working because I took the con back for a second. So I mean,
yeah,
reauthorize you. Sorry.
Okay.
Let me do that. Give keyboard and mouse. Okay. You should be good, Bill. Yep.
Okay. Well, so you assume you want to go into a building and gather information on where the energy is going. How do you do it? What's involved in terms of design and hardware? And this is basically, you think of it as a financial budgeting system. I mean, it's where's the money going? What's important? And so the first thing we do is we draw a one-line energy flow diagram of the entire facility. Where's the energy come into it? Where's it go? It comes in through a main meter, then it goes to transformers, or it goes to boiler houses, or goes to chiller houses. And I've done everything from churches and schools. I'm talking about a lot about industrial because the systems are so complex. But I've even worked in a couple of houses, a big solar house for a while that we took care of. But anyway, you got to know what's there. You got to decide what's important. And I used what I always called the top-down approach, and that is the meters. Every single dollar that you spend goes through a meter. So by just picking up the meters alone, you can get, let's see what's happening here. You can get a huge amount of data because you can see how the facility varies depending on the day of the week, the time of day, the shift, the weather. So the meters are the absolute most important point. And I've been in a number of facilities over the years where I've talked to people and they said, oh, we're already doing that. We have monitoring. We have this and that. And actually I was talking to the head of energy conservation to the state of Texas, and they said, oh, we're already doing everything. And he had his chief engineer in the office. And I said, well, how many meters are you monitoring? He said, how many meters are we monitoring? Chief engineer said, I don't believe we're monitoring any meters. So that's a control system. That's not an energy management. That's not an information system. There's a lot of confusion over that. But anyway, you start the meters, and then you go on down to the next biggest piece of equipment. I call this the top-down approach. Energy management or other systems, they start at the bottom, all the points they need for control, temperatures, and then they build upward. And when you do that, it's very expensive because you have to buy all that instrumentation. Remember, I was buying it myself. So if you start at the main points and the main meters and you get the main loads, then the software in the computer can do the calculations, subtraction. You don't have to monitor everything. But if you start with the main meters, you start with the main loads, the main pieces of equipment. Most industrial plants will have a boiler house, air compressors, chillers, and we're talking, we did gas, electric, steam, water, any utility that people are spending money on and want to manage, we did it. So you go in, you pick the points you want. If we had big motors, we had air compressor systems, and then you look at physically what it takes to tie into those. And we found a lot of really cheap ways to get a lot of data tying into points. I've sat through talks of people on instrumentation and the accuracy and the calibration and all this. You may need that to do meter quality measuring, but we never did it because we have the check, and that's the meter. Every dollar you pay goes through the meter, and no matter what's happening in the plant with our software, and we eventually developed software that mirrored what we did physically in the plant in terms of analysis and all that. But our software will add everything together in the plant and compare it with the meter, and if it's only off a couple percent, that's good enough for us. We don't have to have the very expensive meter quality instrumentation. So, but don't waste time. People go in and they tend to waste time on small systems. We went into a meatpacking plant. I'll talk a little bit about that. But they were using 5 times the amount of energy that they should, and they'd had an audit by and it was in the refrigeration system, and they'd had an audit by the utility, and the company that did the audit recommended new lights in the office. They missed the fact that the overall facility was using 5 times the amount of energy it should for the amount of process that they had there. So anyway, it makes sense. I mean, it's problem solving. If you're an engineer, you got a technical background, you learned at your first day in engineering school. You gather data and you do some problem solving. And the most interesting thing about the meter, I had some nuclear guys, one of the classes, I was teaching a thermal systems class. And after class, they were great guys, sharp guys running a nuclear plant. And they came up and they said, we've had to do that every day of our lives, and we never understood why until tonight. We have to count for every BTU that goes through our plant because we have to count for the fuel. And I thought that's kind of where my monitoring system first came from. I said, boy, if you can do that in a nuclear plant, you ought to be able to do that in any other kind of building. So you can see what comes through the meter. The question is, where's it go? And you just have to track it, just like your home budget. You know how much you deposit in your checking account every month? Where's it go? It's exactly the same process. I started out in small buildings and small plants because for a couple reasons. I thought bigger plants would have people, a lot better staff, which they do. Most of they did then. A lot of them are gone now. But I thought they'd already understand all this. But actually, it's just the opposite. The bigger the facility, the less the odds that someone has understood how all of it works. The biggest physical plant we did was a GE plant in Louisville, 1,100 acres, spending $1 million a month back 15 years ago. So. And we had to, back then, we had to hardwire everything. So with some of the new Opto controllers, the wireless, the smaller packages, it's much easier now to get the data from the energy users, the meters, the significant system, back to a central server, get it on the internet, and then you have access to it from anywhere in the world that you can dial into the internet. So a long way from my Apple II that I put in the first building that I built on my living room floor. So, and the cost is coming down. That very first system we put in had Opto relays in it. So I've been using Opto equipment since 1980, and I've been through every development, and the new stuff is fabulous. It's easy to use. It's I'm convinced. That's all I've ever used. So equipment is getting better, and that's going to keep getting better. And as is the communications with the internet. So once you have the data, you're tied in, you've got the reports, what do you do with it? Well, do what you do with all your other financial data. Let's see. Our system was set up to generate the reports, so we could drill up or down. You could drill from the meters down into the plant, and you could go from 15-minute data to daily summaries. You could look at it in energy, you can look at it in dollars, you can look at it in operation and maintenance. But you do it for the total facility, each meter within a facility, each area, each department, each significant system. We were in a Honda supplier plant, and we actually put in instrumentation so they could break out their costs, their unit costs, and include energy. So every production line, every part, before they were doing it on a square foot basis, which for industrial plants where maybe half their cost is peak demand, that's a horrible way to do it. It's not accurate at all, but it's all they knew how to do it. But once you have the data and you've got financial data, treat it like any other data. Put it in your financial system. Assign responsibility to the managers of each area and department. Put it as part of their goals and their incentives. Incentive is huge, and right now, at least what we have seen for all these years, most times it gets lost. I had a salesman that was so good, he could get into the plant manager, the CFO's office on the first call, and he would sit there and talk to them, and they'd say, "You're interested in cost? Oh yeah, we want to do this. You know, how are you managing all this? Oh yeah, we're doing it. We got the system." And then he'd say, "What about your energy costs?" And their eyes would glaze over, and they'd say, "Oh, you got to go down and talk to Charlie in the boiler room. We don't know anything about that." And they go talk to Charlie. Gary's his name. He'd go down and talk to Charlie, and Charlie would say, "Hell, I just keep it running. I don't know how much it costs." So there's this giant disconnect there. But once you have this data and you integrate it in your financial system, then it can be managed the same as all your other costs. So it just, it never seemed like a mystery to me. But the data also, it does. We found that I've heard people say, "Oh, what you need to do is go back to getting the system running the way they were designed." We find wrong designs, wrong size, poor efficiency under part load, wrong operation, wrong control, wrong maintenance. Once you have data, this verifies that everything in the plant, or it can with the people with enough background to understand it, that the systems were designed properly, that they're the proper size. We found chillers. In almost every case, we found chillers twice as big as they needed to be. And so they limp along most of the time running at horrible operating efficiency with the pumps and the fans using more energy than the chillers themselves. Once you have the data, then you got to display it in a meaningful way. This was the GE plant in Louisville. They had 15,000 horse of air compressors scattered over over 1,100 acres in 5 different buildings. So we had to hardwire and run our S485 cable to hook all the different Opto panels together. But once we got all the data on one screen showing CFM from every compressor, every location, we showed pressures, we showed energy use of each of the compressors. By looking at them individually, they'd done the best they could to tune them. But by seeing it all together, our reports showed system efficiency. And this wasn't an automatic, it's not something they could do with automatic controls. They actually had operators in a boiler house controlling these. So they sat our monitoring screen on their desk, and they controlled the sequencing of the compressors and which compressors are on and off under different load conditions, first shift, third shift, weekends. Within 1 month, the project manager, GE, called me and says, "We've just saved $250,000. He said, by changing the way we were controlling our compressors, we've knocked 25% off of our daily and weekly consumption and cost, and it's going to save us $250,000 this year." This was a GE plant spending $1 million a month. They had 84 submeters they were reading by hand and putting in a spreadsheet. So they weren't managing it, they were reporting it. And these were people that were tracking pads of papers, and they didn't know where that $1 million a month. And as soon as we got in within a month, and we found this everywhere, not in the total facility, but in the major energy consuming systems, whether it's compressed air, chillers, towers, whatever. It's always there, but you can't find it without instrumentation. If I had to go back and tell somebody what I do differently, I don't know. I couldn't do it without instrumentation. How can you fly an airplane without instrumentation? What would medicine be without instrumentation? Why people think they can run complex, expensive systems in buildings without instrumentation is just beyond me. Doesn't make any sense. Here's another report. This was a Rexnord plant up in Indianapolis. spending 30% of their electrical dollars on third shift and making 4% of their product. We took this report, sat down in front of the owner, Herb, the president. He said, "What the hell is going on here?" And I said, "Well, nobody's paying any attention, obviously, to what systems are on and off." So what we did there is we took, we set up our monitor data in reports for each production area, and we printed a report every day that was in the foreman's meeting in the morning, and Herb assigned the responsibility for those costs for those departments to those foremen, and they dropped 35% off what they were using within the first few weeks. So reporting has to be clear too. Not only do you have to have the data, strip charts, you know, for people, engineering strip charts, people to fight through doesn't mean that much. There's a lot of opportunities for avoided costs. I mean, once you're watching what's happening, you're trending, you see something start to go bad, you see a piece of equipment fail. If you're running a plastics line off of, and you're depending on water from a cooling tower, and your cooling tower starts to deteriorate, that could cost you $100,000 a day or something if that goes down. This will warn and alarm you that things have changed, that there's a deterioration, and so there's lots of opportunities for avoided costs that don't show up anywhere because you've never spent the money yet. So the benefits from monitoring, you get those immediate savings. We started creating the first day. Stuff that's on that shouldn't. You look at your meters. Can you account for everything that's where everything's going? We spent, I estimate, we ran buildings for people under contract for years, and we spent 30% of our time undoing today what someone had screwed up since we were in there yesterday. Servicemen, people with no incentive, they didn't really have the training, they jumpered things to run continuously, they changed set points, they turned equipment off and on. Ben Orchard out at Opto, and I've talked about this a lot, he ran 2 hospitals, was involved with running 2 hospitals in Australia, and every time I say that, he says, "Oh, you're exactly right." It's the people. It's every day trying to track. Good instrumentation will show you when there's a change. It'll show you when something's happened. We had phone dialers set up in the old days to call us when something went bad. And the way you save energy is you set your goals every day. Once you see what's going on, you know when the lights should be on, you know how much energy you should use each shift, you know when the how much air conditioning you should be using, you know when the pump should be on, how much the air compressors. So you set goals, and then you track every day just like a budget at home. You avoid the waste, you increase the quality. It's basically, what I've done all these years is basically, I consider tuning up a building like you tune up a car. You get better mileage, you get better efficiency, you get better reliability. That's all you, and you can save 20 or 30 or 40% with basically no capital improvements. This last one's really important because with so many people selling things and promising savings, most of what I've seen have been exaggerated, in some cases outright lies, in a lot of cases they don't really know, they just estimate. But if you have instrumentation, you can verify that every dollar you spend and every dollar you spend on a capital improvement gets paid back. Let me give you a few examples here of things we found. We went into a 20-school corporation. They just spent $1 million on an energy management system. I had seen a report showing how it saved $800,000. We got into the system. We got all the utility records. Of course, the person that reported the savings was also the one that had recommended doing the project. There weren't any savings. The costs had gone up for the first couple years, and then they'd gone back down. We put in our instrumentation. Actually, I was going to use this system. It was unusable. I had to spend a bunch of my own money to put in our instrumentation. We knocked 35%, $500,000 a year off their costs. I got a letter from the superintendent saying we saved 14 teaching positions. So without data and without actual management, I got a letter from Cosmos Cement Plant in outside of Louisville, south of Louisville. Our data showed rising amperage on a 3,000 horse motor. He said they shut it down. It would have been a catastrophic failure. They avoided $100,000 in repair in one day from that data. Meatpacking plant, the one that was spending 5 times what it should. We got into it. They were preparing to, I got a call from the engineer from the utility company. They were preparing to spend $100,000 for more transformers to add more chillers because they were out of cooling. They were having a real problem with keeping the meat cool and keeping everything cool in the summertime. The data from our system showed that they had almost 3 times the amount of cooling they needed already installed. I met with all the president, the plant manager. They said, we haven't been able to cool this plant properly for 30 years. So our data showed we found a 400-ton, 600 kW of false load in the refrigeration system, 24 hours a day, 365 days a year, possibly for as long as 30 years. It was bad valves in their ammonia system. We were able to isolate. By repairing the valves, they now had almost 200% backup. They didn't have to spend anything on new transformers. They also, in this case, found out, once they found out how expensive it was to run parts of that plant, they shut them down, subbed them out, or transferred some things over to their other plant. Actually, Opto just published a case study on this Mariah packing plant. But for 30 years, they've been running it. The refrigeration people, their own people, had not found this problem. This is not uncommon. I was working in a hospital over in Connecticut, and they were getting ready to spend $300,000 on a new cooling tower. They couldn't get the return water from the tower cool enough to keep their chillers and their chill water low enough to maintain humidity in the hospital. We went in there and actually measured temperatures and found out there was mixing in some of the piping and valves that had been installed wrong. And for about, I think it was about $5,000, changed the piping and eliminated the need for a new tower, saved them $300,000. I got a call from the head of engineering, and Ed, his name was Ed, I remember his last name, but he said, Bill, how did you do this? He says, we've had this problem for 10 years. He said, we've had 6 different engineering companies in here. I mean, this is in Hartford. This is high-quality people there. And he said, all we've done is spend more money, buy more equipment, and never fix the problem. He said, how did you do that? And I said, gosh, Ed, I looked in a piping book. I mean, it wasn't magic, but with the data and some research, I said, I'd like to say I'm a genius, but I just looked in a piping book. Apparently no one else ever did that. Interesting. Had a lot of fun times over the years. Foundry. They told us we got involved with this foundry, and they said, well, you can't change anything. You hear that all the time. Well, you can't change anything. Well, they're assuming what we're going to find, and they're assuming what we're going to want to change. And so don't have your mind made up. Don't have canned solutions. Don't say you got to replace this. We went in and instrumented the plant, and we found out their electric furnace was not the bigger user. It was compressed air, and it was horrible. They were wasting huge amounts of compressed air. Compressed air, every place we've ever been, is a huge opportunity for savings. Made some changes, shut some stuff down. I don't know if they ever spent any money, and it cut like 1/3 off their compressed air. This third one was a cement. It was the Cosmos plant out of Louisville. They had 2 mills. They alternated them, I think, weekly or every other week. And they were overlapping the startup and the shutdown. We put the screen of the PC on the desk of the operator, and by watching their peak demand and staging the startup and the shutdown, he cut their monthly peak demand 2,250 kW. 2,250 kW was being wasted every month just because of their startup procedures. So went into an ice arena. They had previously had some big capital projects, spent a lot of money, and cut about 50% off their operating costs. About 3 or 4 years later, we went back in there, still had all the capital, so that wasn't the problem, but their costs were back up to where they had been before. The changes by outside contractors and staff over, I think it was about 8 years, had destroyed all the savings. We put in, they were spending $140,000 a year. They were only open 8 months a year. They were about to close. We put in instrumentation, start tuning the system. We dropped their utility costs from $140,000 for 8 months to $40,000 for a 12-month operation. This project actually received a DOE award for energy innovation. So we saved almost 70% in a project that already had made capital improvements, and they were all changes in operation and maintenance. We monitored some plastic injection molding presses up at RCA plant in Indianapolis, and we found that the presses were off, out of service, not even an operator were using, I think, 85% of the energy that the ones in full operation were. They had hydraulic and cooling systems that ran full out, whether they're in use or not. We found buildings that supposedly were shut off that were still using 75% of what they were when they were in full operation. I spent a lot of nights going around opening up electrical panels with clamp-on ammeters trying to find loads. You go into a building where they say everything's shut down, all our equipment's down, it's down for nights or weekends or vacations, and then you get the data and it shows they got a 500 kW load in there somewhere. So just waste. This last one was funny. We were doing, this was at Rexnord plant up in Indianapolis, and they had people paying them double time coming in on weekends to run through the heat treat furnace, and we noticed the furnace is only drawing 70% of its capacity. And I was meeting with the engineer, and he said, "What's going on? Is something wrong with the furnace?" I said, "No, that electric furnace draws enough. It draws enough electricity to heat the metal that's going through. At certain degrees, it's a specific heat of metal. It's a simple calculation." I said, "Your guys are only sending through 70% of the parts. They're being paid double time to heat." So it's interesting where you find things, but from an audit or a study, you don't find any of that. So everything. I don't want to be negative about the energy profession. I think in a lot of ways they've been driven by selling something rather than saving energy. But the solution, no matter what's bad, what's good, what I don't like or do, the solution is energy. I'm sorry, the solution is monitoring energy. If you get instrumentation in, then it's going to tell you who's doing a job, who's telling you the truth, and who's not. So without it, I don't know how you can. I certainly couldn't do it. So I'm going to summarize, but look at the bottom of this. These are not my comments. This is something written in 1983. I'm going to read them to you. I've been collecting these for 30 years. Energy monitoring and targeting. Here's a summary. It's a management information and financial tracking tool that enables firms to manage energy as a controllable resource the same way as they manage other resources. It shows you where you are, where you want to go, and how you can stay on course. It has to have management commitment, accountability, and data formats that are clear in presentation. Without tracking, how does the energy manager know where to begin? If something is done, how can it be shown that the effort did any good? So this is not something I discovered. This is not a secret. This is not new. This was written almost 30 years ago. I have a few other quotes here. Walt Disney World, 20 years ago. Adequate documentation can only be accomplished by end-use metered evaluation and analysis. The long-range success of any energy conservation program depends on close monitoring of the equipment and operation. Views not backed by data are more likely to include personal opinions, exaggerations, and mistaken impressions. And most of the views that I've seen on savings from projects have been subjective, and they've been not backed by actual data. So in closing, I want to read you a quote from 150 years ago. James Hill, President of Great Northern Railroad. Intelligent management must be based on exact knowledge and facts. Guesswork will not do. That's it.
Great. Thank you, Bill. That was wonderful. I am going to now open up the Q&A. So we've got a question in. And I also want to encourage those of you who haven't had questions sent in or want to make a comment, please do. And let me go ahead and get started with reading our first question. And while I'm doing that, we've got a couple actually, so we'll get going here. And Bill, this first question is from Brian Fisher here in Southern California at Pacific Technical Products, and he says, what is a typical job title of the top management people that make the decisions? Bill?
I don't know that. I'm not sure. Let's see what that would mean. Let me give you the management decisions, we tried and we got in and talked to CFOs, and they're certainly interested. But I have a friend, who's a longtime friend, is retired head of facilities worldwide for Cummins Engine Company, pretty big company all over the world. And I was talking to him a couple years ago about, whether to keep, what to do in terms of what I was headed into here. And he said, unless you have the commitment from the top person in the company, he says, you're wasting your time. He said he did projects all over the world. He spent a lot of money. He had energy managers. He got savings. They were successful. And he said a new VP would come in who was over his area. He'd call Tom in. He'd talk to him, and he'd say, fire all those people. We don't want that anymore. It's a waste of time. The janitors can do it. He said they'd lose all the savings. So I don't know that I can tell you who the top person is, but whoever it is in that chain of command that has the ability to make decisions about whether to emphasize this. One more comment. In the foundry we worked in, the vice president, longtime vice president, took this project under his wing, and we dealt with him, and everyone in the plant reported to him almost on a daily basis about what they were doing, and we showed them the data, and they did it. So whoever the top person is in the line that makes the decisions, if they don't buy into this, it'll fail.
Thank you, Bill. If I could just add my 2 cents to that. There was an interesting Forbes article that came out, I think it was a week ago. I think, Brian, that's being defined. We talked about the disconnect between people running a building or a plant and the people who pay the bills, and I think that model is changing. And the article in the Forbes magazine was how certain CIOs, so the Chief Information Officer, the person associated with IT, was taking ownership at this particular large company of energy. So I think that's going to, as these dialogues start and the awareness comes around, I think that that's going to be defined because there is that disconnect. Let me move on to the next question. This is from Kenneth Sutherland. You've kept your costs down by using Opto 22, the least expensive monitoring system. How do you keep your costs down for sensors and piping modifications? Analog inputs are extremely expensive. What sensor manufacturer and model series have you used to minimize costs for temperature, pressure, flow, and level? Bill?
That to me?
Yes, sir.
I've been doing this 30 years. We made our first, we brought thermistors and soldered them, and so I don't have a canned answer for that. We've used different sources for different sensors over the years. So, and in my case, what I've always done, it's kind of like with Opto. After I got involved with this and started and used Opto data and used certain sensors, once I knew how reliable Opto was and their service, I never even looked around for anything lower price. To me, my time and the integrity of our design was worth more than shopping for the lowest price. So I'm not sure that I always used the lowest price sensors. I found good ones that would do what I wanted, and I just stayed with them. But I think a couple of points here. One is, and I ran into this last week, I had somebody email me about the cost of monitoring power, how expensive it was, and all three phases and amps and volts and all this. And I think my key was not the cost or the quality of what I did, but thinking through what I actually needed and not buying any more than I needed. For instance, I know Opto and their EMU and all, if you want to measure something in detail and you want to measure power and you want to measure a motor or transformer or something, you can do that. But just for energy to see if something's off and on and about how much it's drawing, you only need to pick up one phase of amps. Same with temperature sensors. I can pick up, people talk about, well, we've been working with some big swimming pools and auditoriums, and those places don't monitor their energy separately. So rather than putting in a meter, I can put in a temperature sensor on the return, whether it's water, air, temperature sensor on the supply, manually plug in the CFM or the GPM or read an amperage if it's a variable speed. So I guess my answer is not necessarily saving money in the quality or the cost, other than the actual points and the accuracy that you actually need to save energy. You don't have to have meter quality accurate data to save energy within a facility.
Thanks, Bill. Are there any other questions? It looks like no other questions have come. Oh, we've got one just as I am speaking. So let me go ahead and read that to you. And for the rest of you, keep them coming in. And again, don't hesitate to share comments as well. Next one. Have you projects where you control the energy demand? Could you mention some? This is from Santiago Melendez. So
I always took,
go ahead, Bill.
Demand, it's specifically demand. I always took a different approach on demand. Back in the old days when they were trying demand control and shedding loads and all this, my approach was, if you understand what's happening within a facility through instrumentation, you don't need to, those are emergency decisions that I think often are poor ones or often interfere with production. And we always took the approach, if you understood what creates that demand through monitoring, then you manage those loads so that you don't get into that peak demand situation. Let me give you one example. We did a GenCore plant up in northern Indiana. We did 2 projects associated with the Six Sigma, where there were engineers in plants that were going through Six Sigma training, and they were looking for a project. So they bought our monitoring system, installed it, and used the Six Sigma management techniques to make changes, and they paid them. Well, one of them was a GE plant. He found 25% savings within a month. The other one was a GenCore plant up in northern Indiana. And what they found through the data was their peak demand was costing them a tremendous chunk of money, and there was, it's been a few years ago, but there was some equipment in one process line that was driving that peak, and they moved that process to third shift, and they dropped that peak off of their daytime and put it on their night loads and saved them a bunch of money. But so I guess the answer is, if you understand what's creating your peak and you're monitoring it on a real-time basis, and you have either controls or procedures in place to manage that and to limit it, then my feeling is, that's the way we've always done it.
That's great, Bill, and I can understand that as well, because we at Opto were, once we started monitoring as well, we were able to look at our peak, and with a lot of mid to large size facilities, you have a huge tariff on your peak value, so not on your consumption kilowatt hours, but on your highest kilowatt per month, and there's a big tariff. If you can lower that by some change in the way you do things, it can result in tremendous savings. So
let me. Oh, I'm sorry, I didn't mean to interrupt.
Sure, go ahead, Bill. I've got one other question right now, so if you've got a quick comment on that,
yeah, I have
topic,
a quick.
then I'll move on. Yeah, please.
One quick comment. The ice arena, where we saved almost 70%, they had 3 compressors running to make the ice, and each one had, actually 3 ice machines, each one had 2 compressors. And the way the control system was set up, it just cycled those compressors off and on to meet the demand from the ice, the temperature from the ice. Well, we changed the sequence so only no more than 2 could be on at once or whatever, and it dropped their demand like half and made 0 change in the quality of the ice or the refrigeration.
Terrific. Okay, the next question is from Damon Robbins, and Damon asks, are you seeing bus networks more in the monitoring of energy? If so, which is the most common? And he gives examples of Modbus, DeviceNet, etc.
And I really can't answer that, because we always considered our system as an independent auditing and verification. We wanted to know that all of our data was under our control and was actually accurate, and so we always put in separate systems. We would physically piggyback on sensors or terminals or existing CTs, but we never relied on or tied into data from any place else. And actually, I remember in GE and in Louisville, we went in to put it in, they said, oh, please don't get this in our IT system. They said, we'll lose control and never have any data. They said, we want an independent, standalone auditing system. So I'm sure it works, and I'm sure people are experienced, but that's wasn't my philosophy, and I don't have any experience in that area.
Yeah, Bill, I could maybe add a little anecdotal
Sure.
information for Damon. With BAS systems that are in place, BACnet is very common. Modbus is fairly common. And, we've seen some power monitoring devices that do harmonic analysis, et cetera, that you could tap into. And many of those speak Modbus. So I would say Modbus and BACnet are things that we've seen out there. Hopefully that helps, Damon. Okay, I've got another question, once again from Kenneth. When you paid for the monitoring systems on your own, did the client pay for piping modifications? And how did you do it without shutting down continuous processes? Did you work with an installation contractor? So there's a couple of pieces in there. Let's break them apart. Did the client pay for piping modifications, or did you? That's kind of question number one.
Well, I'm breaking it into two parts. Non-industrial, which we did from '79 until 2000, we paid for absolutely everything. We provided everything, we paid for it, we installed it, and we operated it. So, and so we would provide basically our own electrician, and we just have to work with them. Those were non-industrial. Once we got into industrial, we did turnkey installations. So they bought it, they paid for it. We had, once they bought it, we trained them, it was theirs. And normally we would sub out the installation to an electrical contractor who was already in their facility. In some cases they had their own electricians, but most cases an electrical contractor, and we just had to coordinate. Sometimes we worked over Christmas shutdowns to install things when the power was off. But
yeah, Bill, you hit two of them there. So I think you touched on the last part of that too, shutting down continuous processes. So it looks like you're speaking to that now.
Yeah, and we just we worked with the owner and their contractor, and we worked with however they needed to do that, because they had times during, all the plants we were in had times during the year when they were shut down for maintenance, even if it's only a week over Christmas, and that's when we worked and did it.
Terrific. All right, that's our last question, and what I would like to say is that if you think of other questions after the webinar ends, or have some comments you'd like to share, please do send them in, and you can send them you can email them into me. I'm asinha@opto22.com. I think most of you know my email address, or you can send them into the general Opto emails. So with that, Bill, I want to thank you. Very interesting. I personally really enjoyed listening to what you had to say and learned some really neat things. And I want to thank everybody for joining. And with that, I will go ahead and sign off. Bill, if you wanted to say goodbye to everyone as well, we'll go ahead and close the meeting.
I'm excited. There's so many people, and there's a huge opportunity. And I've been waiting a lot of years for people to start realizing the value of information, and I think it's starting to happen, and I'm excited about it. So thanks to everybody.
Yep. Terrific. Thank you, and I appreciate everybody coming on, and I hope it was useful for you. Thank you very much.